Good morning. Hi, I'm Sherry Prupus. I'm Director of Teaching and Learning with Technology at the VCCS, and I'm also the Director of the Accessibility Initiative. It's my pleasure to bring these webinars to you to help you learn about how to make your courses more accessible for your students. As we've been working with faculty over the last couple of months, what we've learned is that accessibility is a strong part of universal design for learning. And as we think about different ways to present materials initially for accessibility, we find that we're really improving learning for all our students. Today, we're focusing on images specifically for STEM. And with us in the background is going to be Nitesh. She'll be running the slide deck. And speaking for us will be Surbi. I want to remind everybody that there's closed caption. So if you don't see the show captions button, click the more, and then you'll see closed caption. We are recording, and we will get the recording out to you in our next Tech Tip Tuesday. Questions and answers should be done in the question and answer little box that says Q&A, and anything we don't answer in the session, we will get to you after. Surbi, over to you.
Thank you, Sherry. Good morning, everyone, and welcome back to our next session. So in the previous session, we focused on the nuts and bolts about tagging and document accessibility. And today we are actually shifting gears to images, specifically about how much information images carry in STEM and healthcare. And here's the key point I want to start with. So if someone cannot see an image clearly because of maybe a visual disability or a technical issue, they're not just missing a picture, they're actually missing the information and meaning there. So when we talk about image accessibility, we are really asking a single question. Can someone still understand the same data and ideas if they cannot see the image the way others do? So today is not about adding any extra work or making things more complicated. It's all about being precise with information and taking complex visuals, images, and making sure the scientific or medical meaning behind them is still available without watering anything down. So the shift we are making today is simply looking at an image to make sure the information inside the image is accessible for everyone. Now, with that big picture in mind, let's get started. Next slide, please. Since some of you might know me from our previous session, I will keep this quite brief. Hello, everyone. My name is Surbi Lohia. I've worked in the digital accessibility and inclusive design for over a decade, leading accessibility efforts at places like Accenture and SAP. One thing I would like to mention as we talk about images today is that I am 100% visually impaired. So when I encounter any diagrams, charts, or images, I experience them through a screen reader, not visually what you see. I've spent most of my career training teams and building accessibility programs, but my goal today is to help bridge the gap between a visual diagram and the student's actual understanding of the information. So I'm here not just as an accessibility expert, but also as a user who knows how much a good image description really matters, especially in technical fields. So let's move on and see what we have stored in for today. Next slide, please. So here is the overall plan for today. We are going to move from the why to the how. First, we will talk about why image description, also called as alternative text, matters so much, especially in STEM and healthcare, where we see images often carry critical information. Then we will get a bit more strategic because every image does not need the same description. That is, a decorative icon on a slide could be very different from a complex chart or a chemical reaction, etc., right? After that, we will share some core principles of writing effective alternative text. And then we will look at the most important part of today, that is the real-time examples. We'll also look at actual visuals and talk through how to turn them into clear, meaningful information for someone who cannot see the image. And finally, we'll share some tools and resources so that it becomes a part of your regular workflow, not an extra step at the end. So that's the overall roadmap. Let's jump right in and start with why image accessibility matters so much. Next slide, please. Now, why are we focusing on so much on text, especially in STEM and healthcare? So images are not just decoration, they are the data, they carry information. Now, if you look at the image on this slide, we have two versions of the same chart. One without an alternative text. So for a student using any assistive technology, especially screen reader, that is a dead end. They will know an image is there, but they have no idea what it says or what information it holds. On the other hand, we've unlocked that data by providing the alternative text. So the alternative text really explains the exam scores over the time so that the student can understand the trend and meaning behind the chart. Now, the goal here is very simple. We want to make sure the key information is not limited to sight alone. Whether your students are accessing materials on Canvas, in a PDF, or even on a mobile device, the learning should be inclusive by design, not by exception. So basically, if an image is there to teach something, that lesson has to be available in text. If it is important enough to be on your slide, definitely it's important to be described as well, right? So that is why alternative text really matters. It makes the data available to everyone, no matter they see that or not. Next slide, please. Now that we understand why image alternative description in image matters so much, let's talk about how to actually apply them without feeling overwhelmed about it. Now, the key thing to remember is that not every image on the slide serves or on an image serves the same purpose. So describing all the images in the same way does not really work. So to make it a helpful start, um, ask yourself, what is this image doing here? To keep things simple, images usually fall under three main categories. So first, there are decorative images. So these are visuals that add style, but do not teach anything new or do not give any information which is important. For example, it could be an image of a book or a decorative icon towards the corner of a slide just to add some aesthetics. Now, for someone using a screen reader, describing these could actually be very distracting. So the best approach is to mark them as decorative, which you can find in most of the tools that you use. This way, assistive technologies would skip over these images, or it would announce that these are decorative so that the students can actually focus on the main content. Next, we have informative images. Now, these are simple images, or I would say visuals that communicate a clear message, not too complicated one. Think of a warning icon next to a lab safety steps or a no smoking symbol in a hospital diagram. Now, here, the goal is not to describe how the image or icon looks. For example, you don't need to focus whether it is a red circle or a triangle, but the message, whether it is a warning or a no smoking zone, needs to be provided as a text. So the idea is to get the meaning across quickly so that the flow of learning or understanding is not broken for the students. Now, we have the third category, which is one of the most important one in STEM and healthcare, is the complex images, which is where a lot of data, a lot of content lives there. Now, these are detailed diagrams, chart flows, processes, anatomical designs, or even medical images, where there's usually too much information to fit into one short alternative text, right? So the strategy here shifts a bit. The alternative text acts here more like a pointer, something like a graph showing patient's heart rate over 24 hours. Like it is just something that gives you the information at a quick glance. And then the full explanation lives nearby, somewhere in a surrounding text. It could be a caption or a longer description provided as a link. So alternative text is just a quick information about what the image contains. It cannot be too lengthy. Now, if you encounter that there's too much of information, you should definitely provide it as a long description. So the big takeaway here is the goal is to convey meaning, not to describe every single visual detail. Once you focus on meaning, the right strategy usually becomes clear. And now that we've talked about the types of images, let's look at how to turn all of this into clear, effective wordings in our next slide. Next slide, please. Now, before you write an alternative text, it really helps to pause and do a quick mental pre-check. Now, this step alone can save a lot of time and effort for you. Now, suppose if someone looks at a complex image first, the first instinct is often to describe every single thing in it, but that is rarely what a student actually needs. The focus should instead be on the why. Why is this image here, and what is that one thing that students should walk away understanding this image? So the first question to ask is, what information does this image convey in the context of the lesson? Not what does it look like, but what it is actually teaching. For example, think of a photo showing a patient with a skin rash. Now, you need to think, is the goal to show the texture of the rash, the location on the body, or simply that a rash exists? Each of those goals would lead to a very different description that you provide. Now, if texture is key for diagnosis, that is what needs to be in the text description. Now, if it is just a general example, the description can be much shorter and simpler. Another really useful question is, if this image was removed, would student miss something important? Now, this is a great test to identify whether you need to add alternative text and what kind of text you need to add there. Now, if the slide or your course still makes sense without the image, definitely it is a decorative one. But if removing the image leaves a gap in understanding, then that missing information is exactly what the alternative text or the long description needs to capture. Now, it also helps to think about the audience that we are looking at, especially like what kind of audience, who are the target audience, whether it is a description for an introductory course, which might vary from someone from an advanced learners, right? So definitely who is the target audience is another thing that you need to keep in mind. Now, finally, decide whether the image is decorative, informative, or complex, as we discussed, because this decision will guide how much detail you include and where the description should live. So before worrying about the words, just slow down and ask the right questions. Once the purpose is clear, the writing definitely will become much, much easier for you. Next slide, please. Now that we've asked the right questions, the next step is to actually write the description. And this is where having a simple framework really helps. So I would like to use an acronym called ACORN. This is not a globally renowned acronym, just a created one to simplify things. So just like a small acorn contains everything needed to grow a large oak tree, a short piece of text can carry the full meaning of the complex visuals if it is written well. Now, first, let's look at accuracy. In STEM and healthcare, this is something which is non-negotiable. If you're describing something like a titration curve or a medical chart, the student needs to know the key information. For example, where the equivalence point is, what the trend shows, and not just that the line goes up or down. Right. Second, be concise. In most of the cases, 1 or 2 lines are enough for alternative text, as we discussed. But if you find yourself writing a paragraph, that is usually a sign that this information belongs in the main or the longer description, not in the alternative text. Third, be objective. The goal is to describe what is there, not how you feel about it. So avoid words like beautiful, confusing, interesting, etc. Just present the facts so that the student can do their own analysis. And finally, make sure that the description you provide is relevant and necessary to the context. Now ask yourself, what does the student need to learn from this image to meet learning objectives? Now, if that detail does not support that, like the color of a hospital gown, it can definitely be left out and marked as decorative. Now, using this acorn approach definitely helps keep description focused and meaningful, which might look very small, but carries the core message of the images. Now, even with a framework like this, it's very easy to fall into some common traps. So let's look at some examples of what not to do and how to fix them. Next slide, please. As you start putting these principles into practice, it is very easy to fall into few common traps. Now, honestly, most of these come from good intention for sure. So one of the big mistake is being a little vague, writing something like a picture of photosynthesis that tells a student that this image exists, but it doesn't give them a clear science behind it until they're aware of the entire procedure. On the other hand, um, we sometimes go too detailed. This is when the description um, is capturing every single visual detail, every shade of green, every arrows, every labels. And the result, a lot of information, a lot of noise, and the student still misses the actual process that the image is trying to teach. Another common issue is missing the main point. For example, a beautiful drawing of a cell. Now, that might sound nice, but it doesn't help with learning or assessment. What matters here is not whether the image is beautiful, but whether it is showing the cell wall or a specific functionality. Then we also have jargon heavy alternative text, especially in STEM and healthcare. Technical terms are definitely necessary, but the description should act as a bridge to understanding, not a wall of dense language that hides the message underneath. Now, if you look at the slide, you'll see a much better approach. Instead of a picture of a photosynthesis, a clear, effective description would be, this diagram illustrates how plants convert sunlight, water, and carbon dioxide into glucose and oxygen. Now, same image, same science, but now the takeaway is much clearer than the previous one. So by avoiding these common traps, we make the path to understanding much smoother and clear for everyone. And if you're thinking this still feels like a lot to manage, now that's a perfect lead into our next slide, where we'll be talking about how AI can help support this process overall. Next slide, please. Now let's talk about what I would like to call the secret weapon in your accessibility toolkit. Artificial intelligence. Tools like Copilot, Google Gemini, ChatGPT, etc., can be incredibly helpful, or when you partner with, especially in drafting image descriptions, especially I would say for complex STEM and healthcare images, which can be really time consuming as well as vague, right, when you do it manually. Now, before using any of these tools, there are two ground rules or disclaimers, I would say, that I would like to mention here. First, always follow your college or institutional policies around the use of AI before using it. Second, which is completely non-negotiable, never ever upload sensitive student information, assessment data, or any private or identifiable details in these tools. Now, we've talked about disclaimer, talking about its use. Now, this is where the AI can really shine and also where it often goes wrong. The power is in the prompt that we provide. Now, if you give a vague prompt, you will get a vague or generic description. But if you give the right prompt, ones that are specific and grounded in context, you will get much, much better results. So being clear about the target audience, learning goal makes a huge difference when you're writing these prompts. For example, instead of saying, describe this image, you might say, describe this respiratory system diagram for a second-year nursing student, focusing on the path of airflows. Now, the AI knows what level of detail to use and what actually matters here in the text description. This becomes much useful for exams and assessments, especially if an image is part of the test that you want the student to understand the visuals without giving away the answers. Now, you can actually prompt the AI with something like, describe this chemical structure for a organic chemistry quiz, but do not name the molecule or its function groups. This way, the description will support access without compromising the assessment at all. So again, specific context-based prompts can lead to better and more usable alternative text. Much more generic ones will just give you a vague description. Another important thing is once the AI generates a draft or a text alternative or a description, your role is not over there. Expert and manual review is very essential. Now, when AI acts as the assistant and you act as the final editor, accessibility becomes faster, more accurate, and much easier to scale without losing any quality or ethics. Next slide, please. So if you can see in this slide, I think this is a perfect example for why context matters so much when you're using AI for alternative text. Now, in one hand, you would see the prompt is just describe the image, and that usually provides something very generic, like diagram of a human torso with organs. Definitely, this description is not wrong, but it is not very useful either because it does not tell the student what they're supposed to learn from this, right? Now, on the other hand, the prompt is much, much specific. It helps the AI what to focus on and what the learning goal is and what level the student is at, and it will provide the description accordingly. And that extra context changes everything. The result is the description that actually matches the lesson objective and supports understanding. So the key idea here is better context leads to better content. If you define the audience, the intent, and the learning goal, the alternative text becomes a true translation of the lesson, not just a description of what the picture looks like. With that in mind, let's move on to the next set of, I would not say next, to the set of examples where we'll be practicing this in real time and see how this works. Next slide, please. So far we have talked about the what and the why. Now let's get into the how. For the rest of today's session, we are going to look at some real images, the kind of images that you actually put into your course materials. But before we dive into those examples, I would like to give a quick disclaimer here. In the upcoming examples, the alternative text and the descriptions that you are going to see were drafted using AI tools and also reviewed manually. There may be some minor inaccuracies as we are not the subject matter expert in STEM and healthcare. So the goal here is to not to debate the science in these slides, but to look at how the information is communicated to a student who cannot see the image and how to make it accessible. So as we go through these examples, please do not worry if any of the detail in the science looks slightly off, but please focus on how we are trying to make it accessible and the concept around it, and how we are translating the visual into meaningful text, and how the description supports the learning goal. Next slide, please. Now let's look at this first example, which is a classic anatomical diagram. Now, as experts, your brain immediately starts processing the signs, names of organs, locations, all of that. But I want you to pause on the signs for a second and look at the slide, like the questions that are mentioned in the slide. Now, this is your mental checklist for accessibility. The most common mistake that we see is trying to cram everything into the alternative text. Now, if you do that, you're essentially forcing a student to listen every single description before they can even get to the next part of your lecture. So instead, ask yourself, what is the minimum viable information needed to identify this image? If you see on the slide, the alternative text is basically titled for the image, where we are not describing every single organ here. Instead, we are just telling the student what this image is about. So think of alternative text like a street sign. It tells you where you are, but the long description, which you'll see in the next slide, is actually the GPS navigation, which will give you the turn-by-turn details. So by keeping the alternative text short, you're actually giving the student the power to choose if they need to deep dive right now, or if they already know this, they can skip it. Also, I would like to add on here that for these examples and long descriptions, I would not be reading out the entire description. So for someone who you are not able to read the text right now, the PPTs would be shared later and you can definitely read those descriptions. So we'll be talking more about the concept here. Next slide, please. Now, if you look at the long description of the image here, this is the GPS that I was talking about earlier. Now, this slide is the turn-by-turn navigation. If you notice, this is not just a random list of organs. Like if we simply list the organs alphabetically, like appendix, bladder, heart, it might be scientifically accurate, but it would not be accessible. Instead, the description follows a clear spatial logic here. So it starts at the top, moves through the chest, crosses the diaphragm, and then moves through the abdomen, and so on. So this is basically painting an image for the students by describing relationship of each organ and how it is placed. Like the liver is on the right side, or the pancreas are behind the stomach, etc. You're giving the student a mental framework to build the image themselves. Now, the key takeaway for here is practice, like I would call this a linear hierarchy that we need to practice. Now, a sighted student can look at a diagram and zoom in on whatever organ they need to understand or want to see better, wherein a student using a screen reader will not have that option. So they'll have to consume the information in a linear order. So it's not just about naming the parts, it's to decide the most logical pathway for the student to follow, which they can understand the exact logic. Also, one more thing. Now, if required, functions and shapes should also be described separately. Now, everything depends on the context. Now, do not mix the where with the how it works unless the lesson specifically requires it. Keep the description focused on the primary goal of the image. So definitely identifying the primary goal, what is the context that you want the student to understand is the first thing that you need to understand. Now, if the image is about location, you need to describe the location of the organs. If it is about function, you have to describe the functionality and so on. So you do not need to do everything at once in one single description. Next slide, please. Moving into our second example, we've stepped out of the lab and into the engineering workshop. Now, we're looking at a free body diagram. Now, as faculty, you will know these is all about force interactions, etc. If you look at the image, the purpose is not just to say that there is an arrow pointing up. It is actually to show how forces and reactions are identified across different scenarios. Now, you must be thinking, should every arrow be described? Now, suppose if you've got 5 diagrams and each has 4 force arrows, that's like 20 descriptions. Now, if you describe them individually, arrow A at 30 degree, arrow B at 90 degree, and so on, the student will lose the forest for the trees. They'll be so busy trying to remember the angles that they'll miss the actual lesson there. So always think, what is the main context that you want the student to understand? Now, also, if you look at the alternative text here, you're setting up the expectation at one glance. You're telling them this is not just one big complex machine. It's a series of different examples testing the same principle. Now, the takeaway here is don't get distracted by the geometry unless it is required for the lesson. Rather, focus on the relationship, the logic that you want to describe about the image, not just the ink on the page. Next slide, please. Now let's look at how we actually break down one of these engineering panels. So you'll see here we've provided detailed description for panel 1. We've identified the beam, where it's pinned, the direction of the load, and the specific reactions, and so on. So this gives the student the exact same data that a sighted student gets by glancing at the arrows. You'll only be able to see the breakdown for the first panel, but in a real-time scenario, accessibility does not stop there. It is not one and done task. If you provide a collection of 8 diagrams, because each one demonstrates a different mechanical principle, you must provide a unique description for each one of those panels. The concept here is equivalency. Now, if the sighted student needs to see all the 8 diagrams to understand the lesson, then a student using a screen reader definitely needs the description of all the 8 panels depending on the context what you want to explain. Now you've got the template here with panel 1 just like an example, and you can apply the same level of description in rest of the sets if that is what you want to explain. Next slide, please. Let's look at our next example of a botanical cross-section. Now, if we were just identifying this as a plant stem, a 3-word alternative text would be fine. But if you look at the questions on the slide, as faculty, you're not just showing this so um, so that students can say that is a STEM. You're not showing them just a STEM, right? You want them to understand the organization of the tissues, etc. So it's all about the purpose-driven instructions or purpose-driven description. So in a STEM context, the magic of image is in the spatial relationship that you see visually. Now, if a student cannot see this image, simply giving them a list of labels like epidermis, cortex, xylem is like giving them a list of ingredients without the recipe. They'll have the parts, but they do not know how to fit them together. Now, if you look at the alternative text, an illustration of the plant with labeled cross section, it sets up the stage, but because spatial relationship is the core of the lesson, we flagged that a long description is coming up on the next slide. And this is another point that we need to mention. We need to mention the location of the description that we are providing in the alternative text so that the student can identify where to look for the details. So the takeaway here is very simple. Before you write any of the description, ask yourself, if you take the labels away, what would the student need to understand about the physical arrangement to pass the quiz? That's what your long description needs to capture. Next slide, please. Now we're looking at the long description for the same plant stem. Now this is a great example for the image which wears two hats. It shows a whole plant on one side and the zoomed in detail on the other. Now we start by giving the student the layout of the page. We tell them clearly that there are two main parts and also notice how we handle the layers instead of just listing xylem or cortex. Now we use a center to edge the logic. Layer A the center, layer B the middle, layer C the outer. Definitely as subject matter experts, you would naturally think in these hierarchy, but for accessibility, you'll have to say them out loud by organizing the text this way. You're not just giving the student a list of definitions, you're actually giving them a mental map of the plant's architecture. So here it explains how the two image relates to each other. And in accessibility, the connective tissue between images is often just as important, I would say, as the image itself. It is not just describing a stem, it is about describing the process of taking a cross section. This will ensure that a student who cannot see the arrows can still understand that the circle on the right is the magnified version of the specific spot on the left. So it's all about creating a seamless logical flow. Next slide, please. Now let's look at a different kind of complex image into the world of mathematical modeling. Now, when you look at this slide, your expert brain would immediately start reading the latex or the variables in those boxes. But if you look at our checklist, the purpose here is not just to show three different equations. If that was the case, we could just type them out separately. Here, the purpose is equivalence. Now, that means the relationship over raw data. If a student using screen reader just hears the three separate equation read out loud in a row, they might not realize that they're looking at a comparative map. They might just think it's a list of equations. If you look at the alternative text at the bottom, we call it a block diagram. This tells the student that they're looking at a flow of information. So as you design your own materials, ask yourself if the student is the student looking at this to solve the math or to understand how the math is organized. Now that distinction will definitely help you to approach your description in a better way. Next slide, please. Now, if we look at the long description for the same, this is where we take a two-dimensional web of ideas and turn it into one. Now, for the student who cannot see the screen, the description starts by giving them a quick legend description, and it is very important to describe the entire concept of how the blocks are related, not just the position of the arrows. And that is the heart of accessibility for abstract visuals or images like this. As sighted people, we would see the blue arrow connecting two blocks and might instantly understand that it represents the connection or flow. But if you just say that there is a blue arrow pointing down, the student has to do that mental gymnastic to figure out what that actually really means and would not even get the answer. So instead, the description explains the intent of the arrows in this context. This way, the student understands the relationship, not just the layout that is visible. So depending on the context, focus and meaning and relationship, not just the geometry or ink on the page really matters a lot. Next slide, please. For next example, we'll look at the ventral view of the brain, specifically focusing on the 12 cranial nerves, I would say. Sorry if I'm pronouncing it wrong. Now, if you're a student or if someone is looking at this for the first time, it might look like a tangled map. As faculty, your goal would not just be for them to memorize the list of 12 names, but to explain where do these nerves actually plug into the brains. Now, if you look at the longer description, if you've not just listed nerves through 12, like the names, instead, we have grouped them. By grouping them, what you're doing is you're sorting it for students who do not see it. So for sighted students, their eyes naturally group things which are closed together, right? But for a student using a screen reader, they do not have that luxury. So you become the curator for that information. Now, if you notice the alternative text, it's simple and tells the student that the image is of a brain from underneath. So the lesson here is always to provide a camera angle in your own text before you start describing the scene in the long description. Next slide, please. Now, here is the long description that I was talking about. I would like you to check how different it is from just reading a list of 12 nerves. If we just read the names in order, a student would still have no sense of how these nerves are related to each other. So by grouping the nerves by their point of origin and moving from anterior to posterior, you are actually helping the student build a mental model of the brain structure. So now that's the whole point of accessible description, to translate a visual into a logical narrative. Now, if you notice, this is how the description does more than just naming it. For example, an optic nerve tied to the X-shaped structure of the optic chiasma. So this information is not just a random detail. This is what I would call a predictable structure. We move in a consistent direction from top to bottom and explain function alongside location, not just the list of terms that are listed here. And here's the key point. This is not only helpful for people or students who are blind, it also helps people or students who have ADHD, who get overwhelmed by busy diagrams, and it also helps anyone reviewing it on the phone where labels are too tiny to see. That is what we called universal design in action along with accessibility. Next slide, please. For our next example, we are looking at a classic line graph, something that we use quite often. So now when a sighted student or sighted person looks at this, they will not just see the three lines. They actually see a comparison and they immediately notice the blue line from aluminium to like aluminium is steeper than the green line for plastic. So our goal here is to make sure the student using a screen reader gets that same information what a sighted person is getting. So it's very important to provide that visual detail as a text in the summary, in the long description, but it is equally important, or it's a must, to provide a table for the same chart. Now, this is the golden rule for any graphs or charts that you come across. The long description is for summary that someone gets as soon as they look into the chart, but the table is for exact values that a student needs to know. So the takeaway here is very simple. For graphs, give them the story first and then the data. That is how you make the information truly accessible for everyone. Next slide, please. Now, we've spent the last few slides talking about how to write great descriptions, but I know what you must be thinking. If you describe a diagram in perfect detail, have you not just given away the answer if it is for an assessment? And that's a really fair concern, and it highlights an important distinction in digital accessibility, the difference between instructions and assessment. In lecture, you would definitely want to be the GPS explaining everything, but in assessment, the student needs to be the driver. So the goal here is to measure their understanding, not their ability to see a picture. So when you design exam questions, you would like to avoid making the image barrier for them to understand the question. So now, if your question is something like, identify the part labeled A, and the only way to answer is to visually locate the label, a student using a screen reader is stuck. But if you change the question based on the context, to be function based, for example, like which structure is responsible for transporting oxygen? You're testing knowledge here, not vision. So that is the shift we are aiming for. So this is something like the rule for images in assessment are slightly different from what you provide during your lectures. In exams, alternative text should be neutral and only provide orientation. You might write something like a diagram with 5 labeled parts. You're not giving away the meaning, just the structure. And if you realize that describing the image reveals the answer, that is a red flag. And it usually means the question or the testing observation instead of reasoning needs to be changed. So the takeaway here is simple. Accessible assessments measure understanding, not observation. So we want to know what the student understands, not what their retinas capture, correct? Next slide, please. Now, let's look at a practical challenge versus solution scenario. Now, this anatomy model is a classic example for the same, where numbers pinned all over the image, like a visual scavenger hunt, I would say. Now, in a traditional exam, you might ask, what is the organ labeled number 4? But if a student cannot see where that pin is, they can't even start it. The barrier is not their knowledge, it's actually the way the question is delivered visually. Now, so how do we handle these kind of situations? The key is to keep the same learning objective, but change the way the student demonstrate their knowledge. Now, either you can create an alternative version for questions for people using screen readers, such as identify the large organ located in the upper right quadrant of the abdomen and describe its primary function. That still tests the same knowledge, but does not rely on seeing the label. The second path, or the second option, and the one that we recommend, is it's more efficient because it is more efficient, is that to design one assessment that works for everyone. Now, instead of label hunting, ask questions based on functionality, body cavity location, or system relationship. This way, you're testing the science, not the student's ability to interpret the picture. Now, if you notice the alternative text here, it clearly describes the image as an anterior view with numbered labels. So here, we are not hiding the fact that it is a labeled diagram, but we are making it very clear that the image is just a reference, not the source of the answer. So by shifting the assessment focus to function, location, and relationship, you can make your exams more accessible and meaningful for everyone. Next slide, please. Now, if you look at the final product here, for the previous slide, we saw a complex numbered torso model. And here is the long description for that supports it. Now, if you notice, the description does not just say that there are numbers, it actually walks the student through the geography of the organs, starting at the head, moving through the open chest cavity, crossing the diaphragm, and ending in the lower torso. Now, even though if this is an assessment, we are still providing the spatial narrative, but here is the most important catch. If you look at the sample assessment question at the bottom, it asks, there are questions like which organ pumps blood and so on. Now, if you ask yourself, does the student need to see the number or label on the model to answer these questions that are mentioned in the slide? I think no, right? They need to know their anatomy, not the numbers. So by providing these description that explains, for example, the heart sits on the chest cavity and the lungs are either on sides, either of each side, you give a student who's using a screen reader the same contextual clue that a sighted student gets visually by looking at the image. So you're not giving away the answer there. You're just providing the data that they need so that their brain can do the thinking and give the answer. So this is the gold standard here that you need to keep in mind. Next slide, please. For our next example, let's talk about the classic matching worksheet, which we quite often come across. So conceptually, matching is a great assessment tool because it helps association and helps in understanding. But as a visual layout, it's often it's an accessibility nightmare. When we look at two columns with lines drawn between them, maybe our eyes would scan back and forth. But for a screen reader user, it does not scan that. But it linearizes the same thing. If you look at the challenges listed in the slide, if the matching exercise is just an image, first of all, the screen reader sees nothing. If it is a two-column layout without the right structure, the screen reader might read all the system first, and then all the functions, leaving the student to memorize 20 items even before they can imagine how to solve this. Now, that's a huge mental load. And to read, and I think that's a real barrier that they would face. So what could be the best practice here? To linearize the context, that is, instead of visual column A and column B, turn it into a standard multiple choice format, like numbered questions with letter choices. Now, the student will be able to differentiate both system and functions, and they can actually make the connection in real time. So the big takeaway is that layout should not be the barrier. At the end, it's the same assessment logic, just a little more inclusive delivery. Next slide, please. Let's revisit our cranial nerve diagram one last time. So this version has everything, names, numbers, and color coding. And from an accessibility standpoint, it is quite tricky to understand. even for a simple identification test. Now, if you ask what is the nerve labeled X, the alternative text or description would have to give it away, and that makes the assessment very unfair for students who rely on screen reader. Now, that doesn't mean the image is completely useless. In fact, it's purpose for higher order thinking. Instead of asking, what is this? We use the image's context to describe it. We can ask functions-based questions, like what happens if the vagus nerve is damaged. We can move into clinical reasoning, like identifying which nerve is likely involved when patients have hoarseness after surgery. Or we can test relationships, such as which nerve clusters near the junction of the pons medulla. Now, do you see what just happened by changing the questions here? The student's success no longer depends on whether they can see the image or not. It actually depends whether they understand the system and the logic. So for a student using a screen reader, the long description we wrote earlier, that is grouping nerves by region, gives them the geographical context that they need to answer these reasoning questions. And that is the ultimate goal behind it. Next slide, please. Now we have an example with one of the most abstract visuals in the curriculum, the control systems diagram. So as we saw earlier, this image is heavily labeled with formulas, arrows, and symbols. Now, if we were to ask student to identify the formula in the right-hand box, we would be testing their screen reader's ability to parse math, not the student's ability to be an engineer. So if you look at the questions on the slide, we are not asking students to transcribe equations or read labels. We are actually asking them to apply system thinking. For example, we can ask comparison questions like, when would you choose state space over a transfer function? To answer these questions, students do not need to see the blue arrows on the screen. They actually need to understand the logic behind them. So the same logic that we provided in our long description earlier. So by describing this purpose of each block, such as the transfer function, it expresses the relationship in a frequency domain that is understood by everyone. We give students the conceptual tools that need to engage with high-level engineering questions. So this approach actually helps to make a better example for everyone. It stops being a test for can you find the right box and becomes the test that do you understand the fundamental theory of system modeling. Just one question here. We still have a couple of more slides. So do we have 10 more minutes to continue? Can I go ahead?
We might lose a few people, but keep going ahead. They'll get the recording.
Okay. Yeah, sure. So, Nitish, just a confirmation. We are in slide 29, right? Okay.
I moved to
So
29.
here, yeah, thank you. So we've reached our final example for the day, and this is a crucial one. So remember in one of the slides where we described this exact same graph by telling the student that the aluminum heats more rapidly than whatever is mentioned there. In the lecture, that kind of interpretation is a great teaching, but in an exam, that is unintentionally giving away the answer. So here is the difference. In assessment, we do not narrate the trend. We provide the neutral data set. And that is why the first point of the slide is so important. Redesign the long description for an assessment. It cannot be the same as you described it in your lecture. So the long description should deliver the raw data, typically the structure table without any interpretation. We do not say rapidly or gradually. We just provide the time and temperature values, the exact value that you see visually. Why? Because the questions are designed to test the students' ability to analyze the data themselves. So this is the ultimate expression of equity in STEM. By providing a clean, accessible data table, you're actually giving the screen reader the same raw evidence that a sighted student gets from the lines in the graph. So the work of the exam analysis conclusion still belongs to the student and the answer is not given away. So in other words, you've moved from being a GPS to providing the roadmap and letting the student navigate on their own. Next slide, please. Now, accessibility is not a one and done thing. So it is something you build into your workflow on a daily basis. A really useful rule is that if the image disappears, would the student still understand the point? If not, that is your cue to improve the description. Now, you will not have to guess whether your slides, your course materials work or not. Try to use the built-in check-in tools, the AI that we mentioned, and you can check the accuracy that it provides. If you really want to feel what the student experience, you can also try the screen readers like NVDA in Windows and VoiceOver in Mac. Finally, we also have some great resources listed here like WCAG, Section 508, ADA, WebAIM, etc. If you want, you can definitely go there for a quick guidance. So I would suggest do not try to fix everything at once. Start with your next big lecture or your next exam and apply one or two strategies that we covered today. So accessibility is not just compliance, it actually is good teaching. Next slide, please. So before we wrap up, I would quickly like to leave you with core ideas. So alternative text is not just about describing pictures, it is actually about making sure everyone can access the same learning material. Not every image needs alternative text. If it is purely decorative, it can be skipped and marked as decorative. But if the image carries meaning, alternative text becomes important there. A quick way to remember good alternative text is by acronym ACORN: accurate, concise, objective, relevant, and necessary. For complex images, keep the alternative text short and use the extended description elsewhere, and make sure to mention the location in the alternative text. Also, always think about your lesson goal and the audience that you're targeting to. The description should support what you're trying to teach and not overwhelm the meaning. Finally, test it using the tools and generate the same using AI, but make sure that you check manually after it is generated. If you take one thing from today's session, it would be something like alternative text is all about equal access, not just description. Next slide, please. Thank you, everyone, for being here. We have a couple of things more lined up in the next sessions where we'll be exploring images for arts and humanities, followed by video accessibility and how to make Excel more accessible for everyone. So stay tuned, and my apologies for extending this session. We can take the Q&A, or I would get back to you the same with the file. Thank you. Thank you, everyone.
We're going to share the recording as well as the responses to the Q&A by the end of this week. Thank you, everybody, for participating. Stay warm and have a good week. Thank you, Surabhi.
Thank you. Bye-bye.